Assalamualaikum and good morning to everyone. So today I would like to present to you about my final year project, web-based Silat training, Kaedah A with deep learning powered post correction. For project background, Silat Cekak is a traditional martial art that emphasizes discipline, precision and correct technique. However, many practitioners face challenges in improving their skills without constant supervision from experienced instructors. To address this, my project proposed the development of a web-based training system that provides a real-time corrective feedback specifically for Silat Cekak technique. By using AI-powered post detection and movement analysis, the system will help the practitioners train more effectively from anywhere, even outside the traditional class setting. The goal is to enhance the overall learning experience by focusing on precision, accuracy, and consistent practice, giving every user the opportunity to reach their full potential. Next is problem statement. Lack of personalized feedback and monitoring of skill improvement over time in existing application for martial art. The current training technology is not designed for specific needs of Silat Cekak, which require precision, real-time and real-time adjustment. For example, the current existing application are more towards gym exercise, a system where it will show the correct form doing exercise, for example squat or dumbbell press. Practitioners often rely on face-to-face training due to the lack of accessible AI-based tool for accurate technique-focused guidance. For system objective, to develop a web-based self-guided Silat training platform that enables practitioners to train independently, enhancing accessibility and flexibility without the needs of continuous instructor supervision. To compare different deep learning models, for this project I choose LSTM, CNN and RNN for their effectiveness in detecting and analyzing silat movement correctness. And the last one is to improve the accuracy and consistency of practitioners' technique by providing real-time post estimation, visual feedback and automated analysis of movement during both live training and video analysis session. So for Silat Cekak Malaysia, it contains of 4 main techniques, which are Kaedah A, B, C and D with the continuation of 21 movements. For this project, I will only focus on Kaedah A, which will focus on the placement of wrist and opposite shoulders. The system will compare the key point of selected body part, wrist and shoulder. The model is trained to detect and differentiate 3 critical execution phases. The first one is initial state, active execution and the last one is perfect technique. So for proposed solution, model transition from media pipe open post to MoveNet. Initial plan used for this project is media pipe and open post with standard machine learning models, for example like Decision Tree and SVM, but it is shifted to MoveNet via TensorFlow for its lightweight, fast and browser friendly performance. It will enable high accuracy and low latency post detection directly in the browser. Advanced machine learning LSTM neural network replace the classical machine learning model with a long short-term memory LSTM model. LSTM is well suited for analyzing sequence of body movement over time. It will improve the classification of movement phase by understanding the context and the flow. LSTM-based posture classification via flash backend. Extracted key points are sent to a flash backend. The backend will load the trained LSTM model to classify posture phase based on 30 frame sequence, and it will return the prediction and confidence score for analysis. The last one is React.js front end for interactive feedback. Built using React for responsive and iterative user experience. It will display live post skeleton overlay, timestamp feedback on technique phase and corrective instruction like raise your left arm or straighten your back. For system model, there are for system module, there are 2 main modules for this system. The first one is training page, developed for real-time post-training. The start camera button initiate access to the user webcam, or the user also can use an app that can be downloaded on your laptop and phone, called Irian webcam camera app using the browser media device API. Post detection runs directly in the browser to extract 17 body key point from the live stream. The rule-based feedback engine compare the extracted key point to predetermined post range and provide quick rule-based feedback. The show prediction components display the real-time feedback to the user. And the second module is the video analysis page, designed for evaluating pre-recorded video motion. The upload video option will allow user to submit a video file of the practitioners doing the technique. Post detection extract the key point from an uploaded video on the client side, similar to the training page. The HTTP request to Flash API, it will deliver the extracted key point to the backend for additional processing. So this is my project system architecture. User will open the web application and it will log in or register. Their data will be kept on Firebase storage. I use Firebase authentication, and if there are success in login, it will directly to homepage. From homepage, user can choose whether to start using the live training session and the video analysis. For live training session, it will activate the camera, and the post detection will be activated once the camera are open. The rule-based feedback engine will be used when the camera detected user body key point, and it will stop once the user stop the camera. For video analysis, user will upload their video of doing Kaedah A technique, and the system will extract key point with the MoveNet. Then MoveNet will send the key points to the back end, and LSTM model will classify all the action on the video, and the result will display on the browser itself. So for benefit and impact, the first one is increased accessibility and flexibility. Enable self-paced training without fixed schedule, suitable for user in remote areas with limited access to Silat instruction or lack of time. Web-based platform remove the needs for hardware installation or special device. Second one is real-time feedback for immediate correction. System detect incorrect movement as they happen. It will display text-based corrective instruction. For example, lower your shoulder, straighten your stance. This will help user adjust on the spot instead of waiting for post reviews. The third one is independent and autonomous practice. Practitioners can train anytime, anywhere with a browser and a webcam. No need for constant instructor supervision, and encourage self-motivation and discipline in learning Silat. Then the last one is enhance overall Silat Cekak experience. Provide a modern and interactive learning experience. Encourage higher user engagement through visual and performance-based feedback. For entrepreneurship opportunity, the first one is mobile app extension. Expand the system into a mobile app for Android or iOS to increase reach and engagement. Integrate with camera and motion sensor for on-the-go Silat practice. The second one is collaboration with martial arts schools. Partner with Silat academies or sport association to offer hybrid, in-person or virtual training. Can be used for standardized assessment or remote competition. Next is global expansion for other martial art. Adapt the core system for other traditional martial art, for example taekwondo and karate. Use similar LSTM based post correction for international market. And the last one is data analytic and progress tracking tools. Offer premium features like detailed performance dashboard, history tracking, and skill improvement analytics. Sell the performance report to the user or schools for grading and certification. So this is the setup for live training. The user can choose whether he want to use a laptop webcam or earring webcam. Earring webcam will connect your camera's phone with your laptop under the same connection. So here are the homepage for my web app for Silat training for Kaedah A. At this page, the user can navigate to both of the main module of the application, which are live post tracking or live training and video analysis. First, let's see how the live training works. When the user click the live post tracking, it will navigate to the live training page. At this page, the user will see a control panel for camera selection. This allows user to choose which camera will be using during the training. For this demonstration, I choose to use Irium webcam. For Irium webcam, anyone can download it on your smartphone or your laptop. Make sure to be on the same connection to connect smartphone camera to the laptop later on. Then, click Start Training and stand in front of the camera. Make sure whole body are visible on the camera for key point extraction and accurate prediction. You can start the Kaedah A training once you are ready. When you are doing the technique, the system will extract 17 key points on your body. It will show the user on the prediction of the current movement like initial state or pre-flight technique. Along with its prediction, it will also compare the key point to the fixed range. In this Kaedah A technique, wrist and shoulders key point will be compared. If the key points are not in the range, it will show the feedback like make sure your wrists are aligned with the opposite shoulder or make sure both of your wrists are beside your hip or body. Else, it will show positive feedback like good posture. Once the user are done with the training, click the stop training button to off the camera. Next, I will show how the video analysis works. Click the video analysis to navigate to the page. At this page, user can choose whether they want to upload their recorded video during the technique on the left or right hand side. For this example, I will use left hand side. Then, click the choose file button to upload the video, and the file selection window will pop up and choose your video. Once the video being uploaded, user can click the analyze button and wait. This page has the same working step just like the live training but for recorded form. The video been converted to continuous frame, then the key point of the body will be extracted and compared to the range. Once the comparison are done, it will show the analysis result for the video. Here, user can see their video timestamp and the feedback. For example, at 0 second, the prediction is initial state with the feedback, make sure your wrists are on your side. At 1 second, perfect technique with the feedback, lower your wrist. As you can see at the feedback, it also includes X and Y coordinate. This number like 705 or 1047 are unnormalized number for the coordinate. The system compare the normalized key point with the normalized post range. So how does the system get the normalized number for the key point? The system take the coordinate and divide it with the video resolution. For example, for left wrist coordinate, y value 1047 are divided with 1920, the video resolution, to get the normalized key point. The normalized key point then being compared with the post range before send back the prediction to the user. That's all for the system demonstration. Thank you.